What's up, everybody? Okay, so I know we just covered solving two-step equations. All right. And in seventh grade, it's not just good enough to be able to solve the equation. You need to be able to read a word problem and create the equation and then solve the equation. All right. So that's what we're going to do today. I'm going to explain to you, based on like word problems and real world examples, like where we get these equations, what each part, what each part of this equation represents, and then we'll go through some word problems together, highlighting key pieces of information and making the equations and solving them. All right, so I've got this here in seventh grade. And these letters, P, Q, and R, they could be any letters, A, B, C, X, Y, Z, like whatever. It's just these are the ones that I decided to use and that are commonly used. So it says Px plus Q equals R. And this is a basic two-step equation that I showed you how to solve in the first video. And we are just going to talk about like what each of these three letters means in a word problem. So when you find the number in the word problem, you can just pluck it into the appropriate space. So the first thing that's important to recognize is right here where we have our variable x. This variable x is going to be an amount of something that you do not know. It could be an amount of hours. It could be an amount of items you purchase. It could be anything really. And they'll tell you in the word problem, they will specifically either tell you like the variable is how many weeks, like down here, how many weeks W. They're telling you W is the number of weeks. They'll also usually restate it in the question, how many weeks? Again, they're asking you about the weeks. So the unknown variable must represent weeks. So that's the first thing that's important to kind of identify is what is your variable. Now, the number being multiplied by your variable, in this case, P, all right, the number multiplied by your variable, which in math we call a coefficient. In the real world, that coefficient is going to represent an amount per x, right? So if x is the number of hours that your mother works, P would be how much money she makes per hour, okay? If x is the number of apples that you grab at the grocery store, P could be the weight per apple. So it's per 1x. And you're either going to see the word per or you might see the word each, right? That's another option. Or for every x, something like that states like it's every time you see an x, this is how much an x is. All right, not how many an x is. The black right here represents how many x's. P represents how much a single x represents in the word problem. All right, and then in the orange, you've got this like extra q being added on. So however much P times x is, there might be some extra. We call that a constant in math. But in the real world, that could be an additional extra or starting amount. So you might have, you might be talking about saving money at a bank, and you might save like P $20 for every week. But you might have started out with an extra amount already in your savings account. That amount would be Q. That's your starting amount. In eighth grade, we call it the initial value. It might be something like you have a bunch of apples, right? And P is the weight per apple. And then you have like one orange, one extra orange. So just one little additional amount. It has nothing to do with the apples. It's just an additional amount. So if you combine, and by combine, I mean add together the amount that you got per x and then the additional amount, if you add those two things together, you get your total, which is what we see right here in the yellow. And there's really no like real world term for total. It just depends on what the word problem is. It could be total money, total time, total weight. It just really depends on what the question is asking you. And yeah, so we're going to keep that in mind. Our equations are going to be P times X plus or minus, maybe they're taking away some amount, plus or minus Q equals a total of R. And keeping that in mind, we're going to go through and solve equations that look like this, but also as we get through a couple examples, we will create some equations like that, which is 7th grade standard. I believe it is 7EE4A. I will, if I'm wrong on that, I'm going to feel really stupid, and I will go back and fix that. But this is part of 7EE4A. We haven't gotten to the part of 7EE4A that deals with the distributive property. I haven't taught that yet, so no worries on that. But this is part of that standard. So let's go through and make sure we can solve and set up based on these word problems. And I'm just going to write this again over like in the corner of each problem so we can keep up with what exactly is going on. Stop. All right. So we're trying to make equations of the form Px plus Q equals 76. And luckily in number 20, they gave us an equation. They're not asking us to make it, just to solve it. But I still want to point out like why this equation is correct based on this word problem. So it says the equation 8w plus 4 equals 76 models how many weeks? All right, so W is the number of weeks. That's how many weeks it takes a student to save for a video game. Well, this number 8 then, if it's in front of the W, if it's being multiplied by the W, well, this means 8 per week. So this is $8 per week. How did I know it was dollars? Because we're talking about a student to save. It takes that's how long it takes a student to save. Save what? Save money. So this $8, that means this kid is saving $8 per week. How many weeks? We don't know yet. That's what they're going to ask us to find out. But it's $8 per week. Again, like I said before, this number P is always going to be what's per or each or for every. So per week, we are saving $8. And then because there's this little plus 4, that lends me to believe that this kid already saved an extra $4. So he probably already had $4 in his bank account. And then he's going to save $8 every week for some amount of weeks until he gets to a total of $76. Okay. So now that we kind of understand like what this equation is saying, let's try to actually solve this and figure out how many weeks W, it's what it says here. If the student saves the same amount of money each week, $8 each week, how many weeks does it take the student to save for the new video game? So let's go through and solve this and find W, find the number of weeks. All right, I always start with drawing a line through my equal sign so I can differentiate between the right side and left side of my equation. Because this is a basic two-step equation, I'm going to start by subtracting the constant from both sides. Why am I subtracting? Because that's the inverse of addition. How do I get rid of a positive 4 with a negative 4? Positive 4 minus 4 is 0, so that cancels out. And I'm left with $8 per week equals 76 minus 4 is $72. Now, I don't want you as a kid to read this as 8 weeks. This does not say 8 weeks. We don't know how many weeks there are. It's $8 per week. Okay, so just be cautious about how you say it, because if you say it wrong, I know sometimes when I correct kids on that, they're like, oh, you know what I meant. And I'm like, okay, but like if your brain is thinking 8 weeks, you really don't know what you mean. So say it correctly, even though it takes a lot more thought and energy, just make sure you're saying it correctly. So $8 per week, if I divide away the $8, because that's the inverse of multiplying by $8, I'll be left with W equals 9. So how many weeks was I saving? 9 weeks. So if I want to check my answer to make sure I got it right, which 9 is one of my answers, so I'm thinking it's going to be A, I can check that and say, well, if I saved $9 every week for 8 weeks, that's what it's saying, and then I added an extra $4, would I have $76 total? And yes, because 8 times 9 is 72, plus 4 equals 76. So yes, that checks out. This student saved for 9 weeks, $8 a week, plus the extra $4 for a total of $76. So that's where we get the answer A. Number 44 says a caterer makes 6 pounds of trail mix consisting of peanuts and chocolate candies for an event. I kind of want to put either underline or box this information. We have a total of 6 pounds, and look right there. They put 6 right in the slot that we usually put total in, all right? The caterer has 3 pounds of peanuts already. So that's like an extra, like, you know, this consists of chocolate and peanuts. They're telling us right now we already have 3 pounds. We know exactly how much peanuts we have. It's 3 pounds of peanuts. So the other remaining 3 pounds, you might be thinking, well, if it's a total of 6 minus the 3 pounds that are peanuts, that means there's 3 pounds left that must be designated for chocolates. I'm with you on that. But we don't know altogether how many. I mean, we know altogether we're going to have 3 pounds of chocolates, but we don't know, you know, it's not like I can go to the store and buy 1 3-pound bag of chocolate. They don't come in 3-pound bags. Each bag of chocolate candies weighs 0.75 pounds. So if each bag of chocolates is 0.75 pounds, how many bags of chocolates would I need to combine with the 3 pounds of peanuts to make a total of 6 pounds of trail mix? All right. So let's go through. Let's again, they've given us the equation. Let's just go through and solve it for B. All right. So 3 pounds of peanuts plus 0.75 pounds per bag of chocolates equals a total of 6 pounds of trail mix. And let's solve this thing. So let's subtract our constant. Don't freak out that the constant came first in this problem. It doesn't matter, just like it doesn't matter 4 plus 2 is the same thing as 2 plus 4. It doesn't matter if you do 3 plus 0.75b or 0.75b plus 3. Some of my students even take the time to rewrite the equation in this way because they like for the constant to be right before the equal sign, but we'll get the same answer either way. All right, so we subtract our constant. 3 minus 3 is 0. Left with 0.75 pounds per bag equals 3 pounds of chocolates. That's what we thought anyway. We knew it was going to be 3 pounds of chocolates. Divide each pound of chocolates by 0.75. And that means that the number of bags of chocolates we bought, and I'm just going to do this right in my calculator, 3 divided by 0.75 is 4. All right. So I'm getting the answer 4, which is B. I am going to double check my work just to make sure this is correct. If I substitute in, instead of B, I put 4, will I get the same answer? So 3 plus, I go on my calculator, 0.75 times 4 is in fact 3, and 3 plus 3 is 6. So yes, it all checks out, but always double check your answer. It will come in handy one day when you get it wrong.